In Investigation 3, we've been exploring how to solve for missing pieces of information in similar figures with a scale factor. So now we're going to continue to build on what we've been doing with a more advanced problem. So in this problem, we're being told that triangles ABC and DEF are similar, and we're being asked to find the missing side lengths and the missing angle measures. So you'll see a number of question marks here of pieces of information that we want to solve. So let's start by solving for angle B. So take a moment and think about how you would find angle B. So in order to find angle B, you're going to need to think about the sum of angles in a triangle. And I'm sure you remember the sum of angles in a triangle equals 180 degrees. So we have one angle here that's 56, another angle that's 94, and if I add those together, I get a sum of 160. So that means this missing angle here has to be that extra piece to make the whole angle sum equal 180. And so 180 minus 160 would be 20 degrees. So angle B needs to be 20 degrees. So now what about angle E? Well, angle B and angle E, you should be recognizing are corresponding angles. So that means they're going to measure the exact same size. So angle E should also be 20 degrees. Now you're looking for angle F. Again, angle F has a corresponding angle in the previous shape, angle C. And so again, I'm going to just pull that corresponding angle directly there, 94 degrees. So remember, when I have similar figures, their angles are the same. And so I just need to look directly for those corresponding angles, and I can match them right up. Now I'm going to look for some side lengths. And so remember, this is where I need to think about a scale factor. So we're going to start with looking for side DF. And so I'm noticing DF is right here, and I need to think about my scale factor. So I'm going to match up the corresponding sides that I do know. I see 6 and 7.5. So I'm thinking about 6 times what would give me 7.5. I notice that the shape is getting bigger, so I'm thinking about how my scale factor is greater than 1. Take a moment and see if you can figure out what the scale factor is. So in order to find that scale factor, remember I can take the image and divide by the original. So my image is this shape right here, that's what I'm going to. And so I'm taking 7.5 and I'm dividing by 6 to find my scale factor. And when I do that, I'm going to get 1 and 25 hundredths. So again, that scale factor here is 1 and 25 hundredths. So it's getting about 1 1/4 times bigger from the original, which again is this shape here, to the image. So now I can use that scale factor to help me find my missing side. So I can see that DF goes with the side length of AC in the earlier shape, in the original shape. So I'm going to apply my scale factor to the correct corresponding side. So 3 times the new scale factor, so times 1.25, is going to give me this side length here. So again, 3 times 1.25, or 1 and 25 hundredths, would give me 3.75, or 3 and 75 hundredths. And I can also note this is in centimeters. So that's that side length. Now I'm going to look for the other side length, the last one, so FE. So I know my scale factor now. I'm looking for this side length right here. And once I know what side I'm starting with, I should be able to go through that. So originally, this was a side length of 5. But again, I want to find its corresponding side length in my new image, which we've already said is 1 1/4 times bigger, so 1.25 times bigger. So now I'm going to do 5 times 1.25, and I'm going to get 6.25 centimeters. So 6¼ centimeters. So again, in this problem, you can see it's a more sophisticated problem. I'm solving for both angles as well as side lengths. I'm using a scale factor to find those side lengths in particular, but I'm also remembering the relationship with corresponding angles in similar figures, that they simply stay the same. So now we're going to review some of these important relationships from this unit. So again, we're going to talk a lot about scale factor, you can see, but we're going to talk about scale factor in angles, sides, perimeter, and area. And it helps to kind of have a shape in mind. So I'm going to just draw a simple square here with side lengths of 2. And I'm going to imagine that we made another square that's 3 times bigger. So using a scale factor of 3. So these new side lengths are going to be 6 and 6. So let's just use that to kind of compare. So for example, I'm asked what's the relationship between scale factor and corresponding angles? And here, for example, I can see in this square I've got 4 right angles, and in the larger square I also have 4 right angles. So all these corresponding angles stay the same. So I'm just going to note angles stay the same. It does not matter what scale factor I use. If I double, triple, if I make it half of the original shape, the angles themselves stay the same. Next, we're thinking about corresponding sides. So you'll notice, right, when I had a scale factor of 3, each of my sides, my corresponding sides, got 3 times bigger. So 2 times 3 made 6, 2 times 3 made 6 over here as well. So basically, to find the side lengths of the image, and in this case I'm treating this larger shape as my image, I'm simply going to multiply by the scale factor. So if my shape is getting 3 times bigger, I'm multiplying each side length by 3. If my shape is getting 2 times smaller, I'm going to be multiplying each one by a half. All right, the next one is about scale factor and perimeter. So it might help again to think about this example and how the original perimeter was 2 plus 2 plus 2 plus 2, so 8. And the image that we created that's now 3 times bigger is 6 plus 6 plus 6 plus 6, or 24. And so looking at this, I can see that that is 3 times bigger. So to find the perimeter of the image, you can multiply again by the scale factor. So I can find the perimeter of my original. So in this case that was 8. I can simply multiply by the scale factor since I know it's 3, and that will automatically tell me the perimeter of my image. Right? Of course I could calculate this by myself as well, right? I could add up 6 plus 6 plus 6 plus 6 and make 24, but this is kind of like a little shortcut with the scale factor to help me see how it's changing. And then lastly, I have scale factor and area. So my original area is 2 times 2, or 4, and my image area is 6 times 6, or 36. So you might be noticing here that's not just times 3, that's actually times 9. And at the same time though, you might realize that 9 is related to 3. 3 times 3, or 3 squared, is equal to 9. So when it comes to area, I have to kind of expand both directions for the scale factor. So when I'm changing my side lengths, right, I'm multiplying by 3 on one side, but also on the other side. And so with area, it's expanding in 2 different directions since it's including those square units that fit inside. And so to find area, or to find the area of the image, you need to multiply by the scale factor twice. Or we can also say multiply by the scale factor squared. So again, that doesn't mean I'm multiplying 3 times 2. That means I'm multiplying 3 squared, 3 times 3 to make the 9. Because again, if you think about area, I'm making one side 3 times bigger and then the other side 3 times bigger. The last item we're going to look at for your homework is this concept of nested triangles. You're going to see these more tomorrow, but basically they're triangles within triangles. So you can see, for example, here I have this small triangle that is similar to this larger triangle that it is kind of surrounded by. And so what you might not realize here again is that there are two triangles that are being considered, and they have corresponding sides. So that's one of the first things you're going to need to do is match up corresponding sides and angles. So for example, I have a height here of 15 and I have a height here of 5. I'm also going to be looking for a scale factor. So I'm noticing here that this is going from 15 to 5 or 5 to 15. I can kind of look at it either way. So I might think about how 5 times 3 would be 15, right? And so that tells me that there's a scale factor of 3 between these nested triangles. So another side length that I could search for in this particular figure is this side length down here. And so again, it takes a little bit of time to kind of think through what's happening here. But the original, for example, I could say is 12. And so I need to actually apply the scale factor to this 12 right here to find this new side length. And so I'm going to say 12 times 3, which is 36, would be the length of this side length here. So again, I did 5 times 3 to make the 15, and I'm doing 12 times 3 to make the 36 for this whole bottom side length here. Another piece that I could solve for as well would be this side length that is kind of like the small or the opposite side to the base and the height, which we've also talked about calling the hypotenuse since it's a right triangle. And so in this case, I know the larger shape is 39. And so if I went the other direction with this, instead of multiplying by 3, it's actually getting 3 times smaller. So I'm multiplying by 1/3. So 39 times 1/3 is the same as 39 divided by 3, which is 13. So this side length here is actually 13 centimeters. So again, this is an example of a problem where when I can see that there's similar triangles nested within each other, I can use what I know about scale factor to find each missing length.